Students, today we are going to discuss how to find the focal length of two lenses which are kept in contact. We have already studied the derivation of lens maker's formula and lens formula or lens equation. So what is the lens equation? It is an equation relating the object distance, image distance and the focal length. So 1 by f equal to 1 by v minus 1 by u. That is for a single lens. Now we have taken a combination of two lenses. So both lenses 1 and 2 are kept in contact. Individually the focal length of the first lens is f1 and the focal length of the second lens is f2. Normally if you keep two lenses in contact and keep an object on one side of the combination, definitely some image will be formed on the other side of the combination. Is it not? So these two lenses can be reproduced or replaced by a single lens also. The effect produced by the combination of these two lenses can also be produced by a single lens. Then what should be its focal length and what should be its power? Both we are going to derive. Okay. Now you can look at the diagram. Two convex lenses of focal lengths f1 and f2 respectively are kept in contact. Now I have kept a point source. O is a point source of light and it emits a ray of light which falls on the first lens and it gets refracted by the first lens. That refracted ray passes through the second lens and finally the image is formed at I. So I is the position of the final image due to the two refractions produced by both the lenses. Okay. Now you can see that the distance from this point P, let us say, which is the contact point between the two lenses. From P, the object is kept at a distance of u. So when a ray of light falls on the first lens, the image of O must be found on the other side at a position I dash. Okay, I dash is the image produced by the first lens for an object O. Therefore, the distance from I dash to the point P, the point of contact, must be equal to the image distance. Understand? But this image I dash formed by the first lens acts as a virtual object for the second lens. You can see here the second lens is having a focal length f2 and for the second lens this I dash, which is the image formed by the first lens, acts as a virtual object and for this virtual object the final image is formed at I. Understand? Now you will very clearly understand if I will explain by taking the two individual lenses. Understand? So only the lens 1 is taken now. For the first lens, O is the point object and U is the object distance. You can see that the image is formed at I dash. So the image distance for the first lens is V dash. So for the first lens, object distance is U and image distance is V dash. Is it not? So for the first lens alone, I will write the equation for the lens formula. So this is 1 by f1. Okay. This is equal to 1 by image distance V dash minus 1 by object distance U. So this is equation 1. Okay. Now this image I dash formed by the first lens is acting like the object, virtual object for the second lens. Now we can look at the second picture. So for the lens 2 of focal length f2, I dash is the object. Understand? So I dash is the object and I is the image. I is the image. So the distance of I dash to the lens, that is V dash, is the object distance, and the distance from I to the lens, that is V, is the image distance. So for the second lens, I will write 1 by f2 is equal to 1 by image distance. Image distance is V. So 1 by V minus 1 by V dash is the object distance for the second lens. So this is equation 2. Have you all understood the first two equations? So equation 1 is relating the focal length of the first lens with its object distance u and image distance v dash. Equation 2 relates the focal length of the second lens, namely f2, with its object distance v dash and image distance v. Okay, now I am going to add these two equations. Okay, adding. Okay, so adding equations 1 and 2. So the left hand sides will become what? 1 by f1 plus 1 by f2. The right hand sides will become 1 by v dash minus 1 by u plus 1 by v minus 1 by v dash. First you add the right hand sides. Okay, now you can see that 1 by v dash minus 1 by v dash get cancelled, is it not? So 1 by v dash and minus 1 by v dash get cancelled. What is the remaining then? It is 1 by v minus 1 by u. Okay, or 1 by f1 plus 1 by f2 is equal to 1 by v minus 1 by u, and this is equation 3. Okay, suppose the same effect is produced. Suppose if the same effect, that is the final image, is produced at I for the given point object O by a single lens. Same effect is produced by a single lens of focal length capital F, let us say. So you can see here, this is the single lens. Now this is the single lens. So both the lenses together is replaced by a single lens and its focal length is capital F. So for that single lens of focal length f, the object distance is u and the image distance is v. Understand? So the same effect is produced by a single lens of focal length f. Okay, then 1 by f must be equal to 1 by v minus 1 by u, and this is equation 4. So already one equation 3 we have written, and now the fourth equation also has the same terms in the right hand side. So I am going to compare equations 3 and 4. Understand? So comparing equations 3 and 4. The right hand sides are equal, therefore the left hand sides also must be the same. So 1 by f must be equal to 1 by f1 plus 1 by f2, 1 by f1 plus 1 by f2, and this is equation 5. This is the required equation for us. So how will you find the combined focal length? The reciprocal of the combined focal length is equal to the sum of the reciprocals of the individual focal lengths of the lenses. Understood? So this equation can be extended for n number of lenses. Suppose 3 lenses are there, means the third term will be 1 by f3. Like that, the n number of lenses also. But my dear students, what is the numerical value of the reciprocal of the focal length? It is also equal to what? The power, the diverging or converging power of the lens, is it not? Therefore, now power of the combined lens. So power of the combined lens is given by the reciprocal. So reciprocal of 1 by f is p. Understand? Reciprocal, I mean 1 by f is equal to power p. So 1 by f1 is power p1. plus 1 by f2 is the power of the second lens p2. So this is another equation which is required to solve the numerical problems. So when two or more lenses are kept in contact means then the net power of the combination is equal to the sum of the powers of the individual lenses. In this picture we have taken both the lenses as convex lens. Is it not? Suppose you may have to combine two lenses out of which one is concave, the other one is convex. Say for example, okay, one example let us take. So this is a convex lens and its power P1 is equal to 3 diopter for example. Understand? Now it is kept in contact with a concave lens like this and its power is negative. So this is equal to minus 5 diopter for example. So these two lenses are kept in contact. So what is the effective power in this case? P is equal to P1 plus P2 and this is equal to 3 diopter minus 5 diopter. So this is equal to minus 2 diopter. So it is a concave. Understand that? It is a concave lens because the power is coming as negative. Understand that? So the effective focal length of the combination of two lenses is equal to what? 1 by f is equal to 1 by f1 plus 1 by f2. Similarly, the effective power of the combination of two lenses is given by what? P is equal to P1 plus P2. So using this, so many numerical problems like this will be asked in the competitive exams. Suppose if the focal length is given in centimeters, here only you should take additional care. When the focal length is given in centimeters, you have to convert it into meter because the reciprocal of the focal length in meter is equal to the power in diopter. So take care. I hope you must have understood well. Fine.